So this is 3.3, problem 2. This problem starts off by stating a particle moves along the x-axis. Its position at time t is given by x of t equals t over 1 plus t squared. Now t is greater than 0, where t is measured in seconds and x in meters. So the first question is asking, find the velocity at time t. So we can just derive the equation of x of t equals t over 1 plus t squared. So we can just do that by using the quotient rule. And so we know that derivative of the first times the derivative of second minus, or the normal of the second, minus first times the derivative of the second, all over the second squared. So that'll bring us down to this, 1 plus t squared minus 2t squared over 1 plus t squared squared, which gives us the derivative of 1 minus t squared over 1 plus t squared in parentheses squared. So we're going to skip over the second part because that just asks what the velocity is that's up there and when it's moving left and right. So we go on to the total distance. So the total distance over the first 4 seconds is the question, and we know that x of 1 minus x of 0, absolute value, minus absolute value of x of 4 minus x of 1 is equal to the total distance. So we know that 1 over 1 plus 1 minus 0 plus 4 over 1 plus 16 minus 1 over 1 plus 1 is equal to 1 over 2 minus 9 over 34, because that's just all that stuff in there, which is equal to 13 over 17. That's the total distance. And so now we can find the acceleration at time t, and then when is it 0. So basically we're just finding the derivative again, and so we can do that the exact same way we did before with the quotient rule. So we have this derivative, v of t, instead of x of t, so 1 minus t squared over 1 plus t squared squared. And so what we did here is we just FOILed out this to get 1 plus 2t squared plus t to the 4th, which just makes it easier for us to then go into this, which is then the derivative of the first times the bottom minus the first times the derivative of the bottom. And basically down here is we just kept this the same, because instead of having like this, which is much harder, it's just easier to have it like this. And so that brings us to negative 2t minus 4t squared minus 2t to the 5th minus, in parentheses, 4t plus 4t squared minus 4t cubed minus 4t to the 5th, in parentheses, all over 1 plus t squared to the 4th. So then we can simplify that to 2t to the 5th minus 4t cubed minus 6t all over 1 plus t squared to the 4th. And so we can basically just simplify it down to this, and from that simplifying we can get, what we do is we factor out the 2t, and that eventually leaves us with 2t parentheses t squared minus 3 and parentheses over 1 plus t squared cubed. And now, so when we find when is acceleration 0, we just plug in 0 for the acceleration in this new equation that we have. Now, so that equals 0 equals 2t parentheses t squared minus 3 over 1 plus t squared cubed. And then we can just simplify that, because if we multiply this over here, then that equals 0. So we just know that that equals that. So then we can, I guess, factor that and find out that t equals 0 and t equals plus or minus root 3. And so then that's our answer for that. And for this last part, when is the particle speeding up and when is it slowing down? We know that a particle is speeding up when the velocity and the acceleration have the same sign, and it's slowing down when velocity and acceleration have the opposite sign. I got a little cut off there. So from that, we can just then determine that the particle is speeding up when t is greater than 1 and less than root 3, and it's slowing down when t is greater than 0 and less than 1, and also when t is greater than root 3. So basically we just know when the acceleration is positive, when the velocity is positive, and we can match them up and solve from there. And then that's pretty much it. Alright, so that's how you do that. Alright.